Hi, I'm Duncan Kerr, and thank you for tuning in to this episode of the Scintam Podcast. Today I'm joined by Jonathon Mitchell-Smith, CEO of TextureJet. Jonathan, welcome to the podcast.
Hello, Duncan, and it's great to be here.
In this episode, we're going to cover the TextureJet story so far, why there is such a strong aerospace engineering ecosystem in the Midlands, and how TextureJet and Scintam's technologies work. Jonathan, can you tell me about the TextureJet story so far?
Yeah, sure, Duncan. So, bit of kind of background, kind of what we do. So, TextureJet delivers innovations in edge shaping, surface preparation, and part marking for high precision component manufacture. We enhance quality, performance, and yield of our customers' products whilst reducing the costs and environmental impact of our customers' operations. We use a cutting edge electrochemical jet machining technology is our core technology. This empowers manufacturers to selectively modify component features and surfaces with a much higher level of precision and control than previously achievable. Our story is quite long, as we've packed quite a bit in over the last 6 years, but I'll try and give a brief synopsis. So we started out, or TextureJet started out as an undergraduate project at the University of Nottingham back in 2013, led by me, which we built a kind of viable machine using electrochemical jet machining to do things. We didn't really know what things we were going to do with it, but it was just to do things, as universities do. I then took that prototype, developed new ones based on it as part of my PhD, continued to develop kind of first principles of the technology, wrote papers on elements of the technology as part of a kind of small research group focused on ECJM. Once I completed my thesis, completed my doctorate, I was awarded a very small grant or a small amount of funding from the university and EPSRC to explore the commercial potential of the technology and develop a patent that relates to TextureJet's core technology and is still kind of core to the company today. As part of that process, I was put forward by the university's tech transfer team at the time, led by George Rice, for an Innovate UK funded programme called iCure, which I think is the same as Scintam started out, went through the same kind of route. That started my relationship with Innovate UK, which has definitely been fundamental in moving the company forward since then. The programme was designed to take university research and the researcher, very much around the researcher, out of academia and thrust them into industry. Teach them a set of skills and carry out market validation of their technology. So I was then seconded to Innovate for about, I think, 6 or 8 months, during which time we had a section that was the market validation, which was I visited around 16 different trade shows over 12 weeks, all the way around the world. I had hundreds of conversations with people relevant to the technology or had some kind of insight into the technology and where it could be used, so very much about commercialising the technology. That was then followed by writing up a business plan, which at the time I had no idea how to do, so we were taught how to do that, which then formed the basis of a grant. Grant then underwrote the developing of the kind of first technology platform and also the kind of initial setup of the company. I was awarded that, which then obviously sparked the birth of TextureJet in April 2019. I think we made first payroll in June 2019 with just 2 of us, myself and co-founder Ivan Bistarov. From that point, kind of the development of TextureJet has really gone through 3 phases. Developing the technology from the first principles and the patent, technology validation, so saying that what we've got will actually work for an industrial application, and then market validation, so who's going to buy it. Having not much more than that patent application than the first principles, we went through a period of developing more IP around patent family, and early commercial systems funded by further Innovate grants through things like NATEP, ATI, SBRI, and the Sustainable Innovation Fund. Unfortunately, at that time, this was significantly hampered by COVID. So that was around the time of COVID. We were kind of a year and a bit old. At that point, all the companies that we'd been talking to, making good progress with, suddenly closed their doors to new innovation. They simply shut down, people went on furlough, etc. So that kind of commercial exploration very much closed its doors at that point. It did allow us to concentrate very much on technological development, so really just dealing with the technology and getting that right. But it did stall the growth of the company as a whole. There was no investment going around at that time and no new customers.
So how did you keep the business funded?
We managed to get grant funding during that point.
Right.
Through the...
But that's never 100% though.
No, we were lucky. So I'll
Right.
call it luck that we managed to get, there was a lot of money being put into kind of the Sustainable Innovation Fund was definitely one around that time, and that kind of saw us through for that year. It was a lot of luck, and just really, we were very small at that point, so we hadn't grown at all, so we had minimal overheads.
Right.
So we were able to run it through the grant system and, like I say, be able to concentrate on developing that tech rather than having to almost worry about selling things or getting commercial traction because there just wasn't any commercial traction to get.
And when you started out developing this technology at university, did you have any idea that you'd end up running a startup?
So I went back to uni when I was 35. So I already had an idea in my head that whatever going back to uni meant, it meant I had to get a better job. So There was always a commercial end game to going to university. It was to better whatever I was, than where I was before. So there was always an end game of a kind of commercial aspect throughout, and finding a technology that I believed in and had potential. I always felt it had good potential because it wasn't being commercially, the kind of principles weren't being commercially adopted at the time. So
did you have any idea how hard it was going to be?
No. if anybody had told me that, I probably, would have thought very much twice about it. It's
got a good job in a corporate and had an easy life.
Exactly, yeah. Worked my way up through the ladder post. But, I'd stayed on and done a PhD, so I was already fairly well embedded in trying to drive an innovative technology. That's where I was at that point, is trying to find a technology that kind of made a difference. So, yeah, certainly I probably would have been put off, but at the end of the day, given the same opportunities, I probably would have made exactly the same choices again. So,
yeah. So I believe you're mainly into aerospace customers. There's a very strong aerospace and engineering ecosystem in the Midlands. Why do you think that is?
I think it comes back from the fact that all the coal was mined here, and therefore all the primary industries were, set up in the Midlands, steelworks, textiles, and that's led to then the growth of OEMs in the area. And fortunately, although it's no longer the case, a lot of the OEMs have kept their central, operations based within the Midlands. They've got a good skill pool, a lot of world-class universities based within the Midlands, all well supported, all have good connections within the industry. So I think, a lot of the graduates, that's their direct role, is to go into a lot of these OEMs. So that's helped build that kind of ecosystem. I think we've suffered probably in the Midlands with not having the right finance quite a lot of time, outside of the Golden Triangle. But I think that's changing a bit, driven by some of the, VCs are setting up regional offices. So Nottingham, Sheffield, Manchester. Birmingham. And so that's helped a lot. But there's also a big drive from central government through British Business Bank to fund within the Midlands. So, there's a lot of Midlands-based, Midlands-specific funding funds that you can apply for, for equity funding. So, yeah, it's getting better, but that's definitely been a hindrance. A hindrance to us, as a company. It's been difficult to find funding, especially for hardware. Hardware is a really difficult thing to fund.
Yeah. I mean, most of the investors are interested in AI and internet and apps and the rest, and they're interested in hard engineering.
Yeah, hard engineering. It's the long cycle time to establish a product. There's definitely a mentality of flipping investments in the UK. US, some places in Europe, Asia are very different. They like the long-term approach because they see that once you have a sovereign capability of a base technology, that's worth quite a lot in the future. Everything has to be built on top of that. So therefore, they kind of they want to keep those sort of roots in the hard technology. So, yeah, it's different around the world. The UK is certainly a different kind of investment market to the US, for example. So it makes it very difficult to drive, hardware in the UK for sure, develop and drive it.
Well, and one of the key differences between the US and the UK is that they've got a home market that's about 5 or 6 times the size of ours. So they don't really need to go outside their own country to make a successful company.
No, I mean, the majority of what we do is export.
Yeah.
Is export.
As is Scintam as well, yeah.
Yeah, there just isn't the UK drive for new technologies quite often. So you tend to find that it is, Nordics, US, into Asia. It's, that's where the prime markets are.
Who do you find is the most keen to adopt new technology worldwide?
US is very good. They're keen to take innovation to get a technological advantage. Nordics, very good in that area as well. Again, key for innovation. They are, they want this technical advantage over their competitors. I think they're probably the key ones. And again, China is very good at that. Trying to drive things forward first.
Do you worry about IP leakage when going into China?
Yes, we don't sell anything currently in China.
Okay, yeah.
Not out of. It's a massive market, and we're not in a position to kind of address it properly yet.
Right.
So we haven't concentrated on it so much. I mean, we're the only people that develop this technology commercially. So it would still take a long time to catch up, and it's probably cheaper just to buy machines than try and develop it.
That's a good segue into just finding out how TextureJet's technology works.
Yeah, sure. So trying to keep it simple. It's an electrochemical process utilising electrolysis. So it's basically the reverse of electroplating, if you like. It uses a stream.
Can you make it more dumb even than that?
Yeah, so it uses a stream of salt water.
For our listeners, what is electrolysis?
Trying to make it simple. Well, it uses a stream of salt water,
right?
That comes from a jet. You then put a electrical current between the nozzle where the stream's coming from and the surface you're trying to machine. You can then remove material at the surface by ion exchange. So it's very much like a battery. But instead of in electroplating, instead of where you're plating whatever precious metal onto a cheaper metal, in our case, it removes the metal from one side but doesn't allow it to plate on the other side. So we can very controllably remove and very precisely remove material from the surface. We're doing it at an atomic level. So, we can do depths of 1 micron.
So what's the key difference between your technology and electrical discharge machining, which is what Scintam does.
Key differences: ours is athermal, so it doesn't require heat, which means it doesn't cause any sort of damage or cracking or anything on the surface. There's no recast layer. So that's key. Ours is, like I say, it uses it's electrochemical process, so it's an ion exchange outside of being a discharge where it's actually ablating the surface, so removing by force effectively. Ours is kind of related to as a soft process.
And so the depth you go is much less than what we do, isn't it?
Yes, yeah. We concentrate on the top couple of millimeters of the surface of a component. We can do, like I say, as little as 1 or 2 micron down to a couple of millimeters. We do cutting where it's deeper, but then it becomes, when you want to remove large amounts of material quickly, there's other methods. Ours is where it wants to be done very, very precisely. So where it's very precise and you've got a very strict set of requirements, that's where our technology really works. If you want to
So
brute force,
what are some examples of applications?
So our 3 main ones are kind of deburring or edge break, which is the technical version of deburring, where you're putting an exact radius on a corner of a component.
Right, yeah.
Surface prep, which is replacing things like grip blasting. So we're much more repeatable than grip blasting. We don't have all the environmental impacts. So doing a surface before coating, before painting, before adhesion, or just because it requires dressing for some reason. And then part marking. So for part marking, it's especially relevant to safety critical applications. So where there's a lot of stress and strain, because we don't change the surface and we don't cause any kind of crack initiation points because there's no heat going into the surface. When the parts that are marked are used in kind of high stressful conditions, hot conditions, whatever, it doesn't affect the metallurgy. So for them particular use cases, that it's a great technology. It's really easy to kind of document the return on investment for it.
So your main markets are what?
Precision component manufacture, and that spreads aerospace, defence, power gen, medical. Main areas really are kind of at the moment aerospace, defence, and power generation.
Right.
There are
And
main markets.
I hear via the grapevine that you've recently had some successes. So what's that down to?
What's it down to? Do you mean in the form of kind of machine sales or?
Yeah.
Yeah. So a lot of it is finding where the application fits, where the technology fits. So in our case, it's where they've required something that's very high precision and easy to automate. So really strict conditions for the components, for the design. So very, very high value components. They can't afford problems with repeatability. They can't have scrap. They can't have, yield has to be 100%, especially because of the amount of value add that's gone into the component by the time it gets to our process. They can't afford it to be scrapped. So therefore, it's got to have something that's very repeatable, very precise, very safe, which just fits with any kind of modern workplace, very environmentally friendly.
If you were to go back and do things differently to get where you are now, but without all of the mistakes and mishaps and misfortunes, what would you have done differently?
What would I do differently?
I'm not picking on you specifically. I know all startups have problems.
Most of your problems come from people or money. I've been very lucky around people, very lucky to have a very good team that are very skilled, have stuck with us, and that has been more luck than judgment, I think. Surround yourself with talented people. You can kind of, that's the best way forward, who all have the same vision. If they don't have the vision, they'll get off the bus. It's not going to work because it's tough. It is really hard. To take these things forward is hard. I think understanding the finance and the investment market better earlier, and kind of how that works would definitely be. But again, been quite lucky in that respect.
Mm.
Our investors continue to reinvest, they continue to stand by us, push us hard enough as you would. It's their money.
Yeah.
But understanding that whole ecosystem earlier, but I think you only get that with doing it. So, outside of that, I would have liked to have not had COVID. That would have shortened our developed time by probably a year to 2 years. Be a
Yeah.
year
Yeah.
further on. That would have been helpful. Outside of that, it's we've got to a pretty good place in a pretty good timeline for hardware. There's a lot of
Yeah.
people that aren't advanced or fall by the wayside. We've 6 years in and we're still going and still growing. We're just closing out at another investment round. So it's all good, and the marketplace is good at the minute for reasons that aren't so good. But the marketplace is pretty, fairly buoyant. Although some countries are a little bit hesitant about things, a lot of countries are
Mm.
definitely
When you say the
investing.
reasons are not so good, what do you mean by that?
Um, where they're not so, where they don't quite know what's going on with, where people are a bit shy to step out of their comfort zone. I
Right.
think the UK is probably part of that, where people aren't exactly sure what's going on. They're not kind of, they're hesitant to do new things because they're not sure where they're going to end up with it.
Right. Yeah. Well, thank you so much for coming on the podcast. It's been brilliant to talk about these topics with you.
No problem.
Um,
Thank you.
yeah, and it's great to hear your story, learn about TextureJet, and that it's a positive story and things are going well. It's fantastic.
Yeah, thank you very much. Thank you very much for having me, Duncan.
You're very welcome. Goodbye.
Bye.